There's the little red mark there. Uh-oh. Hang on. Well, weird. Oh, wait. Oh, it is going. Okay. No, wait a minute. Give me a minute to find out. Okay, there we go. Okay. Used to save between the sessions. Now it asks. I don't know where am I going to end up at. Oh, I guess I started from the beginning. Well, so let me kind of pick up where we were. We went through some of these. I think I've assigned a couple of those, but those are based primarily on the concept that here, I'll go back. This is just kind of a quick. This is based on a concept that actually we did before, where instead of these two, you had velocity is equal to ds dt, and you had this, which is the same thing as acceleration, dv dt. So all this is the same thing as chapter 12, except velocity was exchanged for omega, s was exchanged for theta, and acceleration was exchanged for alpha. The way you work all the problems is exactly the same, except now you're talking about rotational motion, and that's it. But let's go on to the next. We started talking about it last time. So once you have that down, your next thing is to, okay, I mean, that I'll save, or I guess I'm not saving it, but I think they're teaching that course in the fall. Mechanisms, I think. And so that should be saved for there. And then what we'll do is go into the instantaneous part of it, in which, you look at the displacements, and there's a portion only due to rotation, and the others are not. They have both of them. And so the best thing to do is for me to haul off, use these equations, and work a problem. And so what I'm going to do is just dig. There are problems there already, but I'm going to go dig down into the book and find, I don't know, that one looks fine to me. This other one looks fine too. But he just says set up the equations. He doesn't say solve them. I think I would just as soon go ahead and solve them. For that matter, I don't know which one might be the best here. This one is more of a complete one, so I think I'm going to do this one. So here. Usually the best thing to do when you're trying to get the point across is just go ahead and solve a problem. So let me just do that. Okay. Okay. So he just said set up the equation. So what I'm going to do is I'm going to go all the way through it instead. So what I'm going to end up finding is I'm going to find the velocity, of course, of point A equals to something I plus something J. And then I'm going to find velocity of point B equals to something I plus something J. Now, that being the case, here's my X and Y. So the first thing is the relative equations. So, okay, I have A and B, but I guess I'll list this as point C and this is point D. He didn't give me those, probably because he wasn't interested in me solving the whole way through, but that's okay. I'll go ahead and do that. So really, first thing, I mean, this is a dumb thing to say, is to identify the links. Okay, so you got AC as a link, all into itself. AB is a link, all into itself. And then B and D is a link. So there are 3 links here. Usually there's actually 2. So this is a kind of a complete problem. So this means I can do this. So if I take a look at each of these links, I'll move this to the side, and then I'll move them down below. I'll use these 2 boxes later. So what I'm going to do, I'm going to say the velocity of A is equal to velocity of A relative to C plus the velocity of C. That's given the fact that these are on the same link, so I can write them that way. I cannot write this. I mean, I can write the equation, but I can't do anything with it. Equals to velocity of A relative to B plus velocity of B. The thing is A and B, I'm sorry, I should have written C. So the thing is, the distance between C and B changes. It's not constant. So it's not on the same link. So this is useless. I mean, the equation's there. You can write the equation, but it's not going to do you any good. So the best thing to do is to identify the links and work your way through those. So the first thing is, it looks to me like this by nature is going to be 0 because the C, the pin, is pinned to the ground. So then the next thing is this. Omega AC has a vector, so this is the rotation of this link right here, crossed with R, A to C. So this is convenient because I can really take a look at it, and I don't have the complication of the other term to think about, although it doesn't really matter even if I do. So the thing is how do you find this and how do you find that? If you can do those 2, you got it. So let's start with this one. You got a vector that is the position of A relative to C. So in other words, you draw a vector that's like up towards here, and it's just that vector. So this is R, position of A relative to C. Person who sits on a seat. Thing is this is just a special case because C sits still, but it wouldn't matter even if it was moving. In a minute we'll see that. So that vector looks to me like it's, okay, that looks like it's a 2 sine 30, is it 30 degree right there? Hang on, RAC. All right, so in other words, what I'm trying to do is I'm trying to do this. I'm trying to find this vector component here and this vector component here, and This one would be 2 cosine 30. And this length is 2 sine of 30. And so then I just list these two in the vector. So I did the 2 sine 30 right there. And then I do the 2 cosine 30 right here. So there you go, I got that. The next thing to solve this is I got to come up with that thing. And with that, the best thing to do is pay real close attention to this and the right hand rule. If you put your base of your hand on X and rotate it to Y, like so, then the vector pointing towards you is a positive K. And so the rotation this way is positive. Rotation the other way is negative. And so what do we have here? We actually have rotation. Okay, we've got rotation this way. So we've got this omega AC, and it can be written the same thing as omega CA.
I didn't get that. Could you try again?
So that's just to show you that they're always listening to you. Omega AC is, so the notation on the bottom here doesn't matter, but it's actually equal to minus 3K. And again, the reason it's a minus 3K is that the rotation that I've got here, the rotation I've got is that one, and this is the positive one. And so I've got a negative there. So with that, I get omega AC or omega CA, doesn't really matter, equals to minus 3K. So now I've got both these vectors, and I can look real close at what velocity A is. It's just, I mean, the book, sometimes he does it either way. He will go in, and at times he does it off of the crosses. But to me, I like to be consistent and just use the little determinant of this thing. So what I do is, since this one's first, put it in here, minus 3. And then this is the other one. The second one goes in below it. And I'm going to zoom in so I can write that. Otherwise my handwriting becomes too large. Wait, was it cosine? It was sine for the X, wasn't it? Yeah. 2 sine of 30 and 2 cosine of 30. Now, I got to make sure, let me just double check. Yeah, they're both going in a positive direction. I had to think about that for a second. So if you do this, what you end up with is a velocity vector that looks like this. I take the cofactor expansion, so I kill off this, and then take this and put it next to it. 0, minus 3, 2, cosine 30, and 0. And then with the I kill off these two, and I take these two, but I've got to make sure it's minus 0, minus 3, 2 sine of 30, and then 0. And then with this, I kill off this and this, and take these, put that over there. Okay, so end up with plus K, 0, 0, a number there, and a number there. However, these two, this whole thing becomes 0 here anyway, which is why I didn't want to write that down in that thing. So now it's a positive. Okay, did I make a mistake? Oh, sure. So that is just, so think about it like this. The one on the bottom is where you're located, and this one is where the vector goes to. And so physically, wherever it is, you have 2 points. You just draw the vector from from C to A, and then work it out. And that's it. That's all. Yeah. 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 And so that's all you're doing. And what we'll see in the next one, and then all the way through this. That's all you're doing. You're going to be drawing vectors along these lengths and then writing them down. Yeah, you're given this 3 radians per second. Yeah, so you're given the angular velocity. You're given the angular velocity. Sort of. It is sort of. They go in hand because actually, in order to get that moving, you got to put a moment on it. Or, it's kind of weird. It seems to me that when something's moving, they like to call it a torque. But torque in a moment's the same thing, really, except you go to the car thing and you want to torque your bolts on your wheel, you get a torque wrench. I guess you could find one that's called a moment wrench. I don't know. I generally have seen them as torque wrenches. And people generally tend to think torque, I don't know. That seems to be a more common term. I don't know why it's mixed up that way. I don't know why there's a lot of stuff the way it is. Here. So here I'll go in and you do the positive and the negative version here. So you do I. Okay, so these two multiply together to give you positive, and then they come back apart and give you, maybe I should move the I over. 3 cosine 30 I. I don't like that color because it kind of seems light there. And this is positive, and this is the negative, but it's already a negative. So there's a negative here, and a negative because of the past. So you've got a minus 3. You know what? I forgot to put the 2 right there. Okay, 3 times 2 sine of 30. Let me show you where I forgot to put it. It's supposed to be right there. It's supposed to be minus 2 cosine 30. I'm sorry, not minus, but plus. I don't know why I skipped writing the 2 there. Wait, yeah. Both of them are there, and I don't know what happened. I just missed that. So in that particular case, well, you know what? Let's say I didn't catch it right there, and let's see what we end up with and see if we can diagnose an error. So we're going to work with the error existing, and I'm going to say, okay, you keep working and you say my velocity A is equal to minus 3 cosine 30. So we know that's wrong. And then minus 6 sine of 30. So you keep working the problem and you're basically carrying this through, but there's a problem here. How do we diagnose it? And how do we figure out what might be wrong? Or if it's trustworthy, can we trust this? And so one of the things is, we talked about this before, some vector C that was generated from A cross a B, just any old combination. If you take a vector A, you take the vector B, and B, you're crossing it, you're going to get some vector C, but that vector C is going to be perpendicular both to A and B. In other words, C dot A, because they're 90 degrees apart, is going to be that, and C dot B is going to be that. So we'll use this kind of concept to see if I can figure out if I can diagnose, not necessarily diagnose, or figure out if I can trust this. Can I trust this? So you look at it, and the quickest thing you can do is this. You can look at this row, and dot it with this. So what you'll get is the first component times this, the second component times that. Well, that's a pretty much straightforward thing. That doesn't get you anywhere. It's when you look at this one. I'll take this component times that one, and I'll write it actually down. And so what I get is 2 times 3, a minus 3, so that's a minus 6, cosine 30 and sine 30. Now I'll take this one and multiply it times that one and put down here. And what I get, that's a 30, is I get 2, okay, minus, so that's a minus. I get 2 times 6, or 12, sine of 30 and cosine of 30. Here. So that's what I mean, sine of 30 and cosine 30. So this cosine 30 and sine of 30. But the first thing you see is this is not equal 0. So this should make you worry for a second, say, hey, you know, somehow I messed up. So the question is, how do you, where, then you know to diagnose it. So here, I can go back here. Okay, this became the positive. This became the negative, but there's one negative there already. So then what I get is 2 times 3 times cosine. So then this becomes 6 cosine. Now, if I go through and diagnose this, I'll take this term times that term, and then I'll add together with this term times that term. If those add up to be 0, then at least the dot product, there's no guarantee that it's correct, but the dot product, or this kind of concept here, satisfies. It satisfies the concept that the velocity is in fact perpendicular to that arm. In other words, the arm goes right here. The velocity is velocity is perpendicular to that. And what it will do is I'll use that to show that in a minute. So at least I can trust that. So now let's see if this makes sense by using the picture. Again, I'll just copy the picture and drop it, say, right there. So let's see if I just so happen to try my best to put this on there. So what I'll do is take this component first. That goes out a certain direction here. Here, let me use a different color. It goes out a certain distance here. This one goes down. And if you put them together, you should get a vector. Oops. You should get a vector that goes exactly perpendicular. Sorry about that. To that. So this vector is perpendicular to that. That's what we just showed, is that this vector, so I can, here, I'll draw it this way. So here's my R, but I can take that R and move it anywhere. So I'm going to move it right there. And I'm going to say this vector, which is the velocity, which is what I got right here, these two terms, is in fact perpendicular. So if you dot R A, and this was C, you dot these two, you show that they're perpendicular. So at least the velocity is perpendicular. So now what do? We got all this. I don't know what else to do except recopy this. You know what I'll do? This is one advantage of doing the lectures this way. You can do if I can hold my finger on the pen long enough. If not, I'll have to use this. So I'll just move this off to the side. But then what I want to do is I want to do this. I want to go in and I want to copy this. Do a copy. I'm going to come over here somewhere. do a paste. And so now there's our starting spot for the next part of the equation, or next part of the problem. So the next part of the problem is, here I gotta hit the escape. Sometimes it's in this weird mode. The next part of the problem is I want to run down link AB. Okay, maybe in the meantime, what I could do is run down the link. So here's what I'll do. Maybe I'll do BD first, or DB, and then what I'll do is save this one together and move it down there. And you'll see why I'm doing that in a second. So if I look at the, okay, now I can remove a lot of this out of the way. So I have this link. I'm going to look at it and I'm going to say, what's the velocity of B is equal to the velocity of B relative to D, which I have to include the velocity of D, but it's fixed to the Earth or some fixed location as well. Now, I can go in here and do this and say, I'm going to just assume this link to go this way. It's a positive. So here's the thing. I'm going to say it's a positive omega B D. And you know for a fact it's not going to be going that. Well, it might be, yeah. Well, no, it won't be going that way because this link is going that way. It's going to be pushing the velocity that way. Push it this way. That's not going to be the case. But I'm going to let the sign convention take control of this. First is, the thing is, okay, my brain froze. Okay, here we go. First thing is omega BD, which I don't know what that is, cross R, and I match the subscript down here. And then I draw a vector from D straight up here. It's a terrible vector, but it's at least it's somewhat seeable. It's just this. There's just a J component. There's no I component. And it's the distance is the same thing as that. So it's 2 cosine 30. That's it. Now omega BD I don't know. So I'm going to carry out the multiplication. I, J, and K. I'm going to slip the first one in here, which this now is a variable, unknown. I don't know it yet. I'm not going to know it for a little bit. And then I slip this in to cosine 30 right there. So I'm using C for just cosine. And now I start multiplying these things out. And one of the things you notice, and I'll do it completely out first. I'll do the I. The I is going to have a 0. Again, I'm taking that out, taking this, and that'll be the determinant. And 2 cosine 30 and 0 minus J. Now here I strike that out, I strike this out, take this, and find the determinant of it. Interestingly, I get this. Whenever you have either 2 rows or 2 columns or both, this whole thing is gone. And you'll see the same thing here. I take this, strike it, take that, put it down here. 0, 0, 0, 2 cosine 30. And, of course, this term is going to be 0. This term is going to be 0. Why? Because if you did the cross here, multiply those two, add them to those two, you're going to get nothing. So all you're going to get is this. Okay, 2 cosine 30. Maybe I'll put the omega in front. 2 omega BD, DB, it doesn't really matter. I that is the velocity of B. That makes sense. It's got to go this way, so I hope I got a negative. If it's rotating this way, I should have gotten a negative. And guess what? So already, this is positive, assumed to be positive, that's positive. This is in other words, this is plus, and the other one is a minus. So in fact, I wrote it down incorrectly. Minus. And that's pretty much it. So there you go. You've got this component going to the left. So you stop and hold. So here's what you could do. You could say, well, this is an important equation. This was an important equation too. So I'll put a green box around them. And now, how are A and B related? Well, they're on this link right here. And because this picture is getting very confused, I'm going to do a copy and move it down and restart it right down here. So now I'm working only in A and B. So technically, here's what you could do here. This is AC, problem AC. This is the problem. Oh gosh. This is the problem B and D. And what I'm about to do is the problem AB. You notice every link has an equation. There's a common pin between all the links. So what you're doing is you're working each link. You'll go through the common pin onto the next link. The sequence you do it in is up to you. Sometimes you can see that you'd have an advantage of doing one over the other. I paused for a minute and recognized that, I knew that this velocity was going to go either to the left or right. But I started thinking I would just as soon have the equation related to the rotation of this link here. And if I can do that, then I've got everything. And so that's why I stopped and did this BD before I decided to do AB. So let's do AB. And I got my picture down here. So that way, okay, so it depends on which one you want to do. It doesn't really matter. Velocity of A is equal velocity of A relative to B plus velocity of B, but you could have easily done this one. And you'll get the same answer. And the difference is, if you look at each of these, you'll realize you're either going to make the vector go like this, or you're going to make the vector go like that. And one vector is the opposite of the other. This velocity is the opposite of that one. And that's the only difference. I mean, there is no difference between these two. So you just choose one of them and go with it. It doesn't really matter. So here you focus on this. Omega AB cross R A to B. So you take the vector, its base is at B. You draw it back this way. It's best to maintain the coordinate system throughout. This is a positive rotation. So I've got that vector. That's a pretty easy vector to remember. In other words, this is R, the location A from B is equal to minus 3 meters right there in the I. So that's really easy. Likewise, the position of B relative to A, believe it or not, going to be 3 plus 3. So if you turned around and did this the other direction, that's what one vector is the opposite of it. So it's not anything, nothing really fancy there. Now, we don't know this yet. I like to assume all positive rotation, so that's what I'm going to do. And so I'll write this term and then fill these two out in a second. So I'll say ijk, this, omega AB. It's rotating in a plane, so it never has a value there or there. And then the pretty simple vector here, -3, nothing. So I'm going to just carry this out and fill in these in a second, just to focus on this. So I'm focusing on the rotation of the arm relative to a person that is glued to point B. So what I've got is I. So if I clear this out and clear that out, I'm not going to get anything there. Now, if I clear this out and clear this out, I will get something. So I'm going to start paraphrasing things here a little bit. I'm just going to look at this, which is -3, omega AB, and 0. So again, let me repeat myself. If I do the I component, I take this out and this out, take the determinant of that. That's not going to get anything. If I look at the K component, take this out and this out, take the determinant of that. So the determinant of that is going to give you nothing. So there's only a J component. And that makes sense. Now the reason I'm ignoring this right now is I'm just focusing on this component. And let's keep focusing on it. This is the positive component. This is the negative, but there's already a negative. So negative of a negative of a negative is -3 omega AB, J. So this is the velocity. I'm going to write back with this. Velocity of A as if you're sitting on B. Let's focus on that thought right now. And then we'll add the parts to it. And so what I'm going to do is copy this, go down here, and we're going to focus on this thought with this. Now, so we're only looking on this, and we're going to diagnose it. Well, I mean, one of the things we could do is take the dot product of this vector. Here, I'll do that real quick. So here's our quick check. The X component, here, I'll write it out completely so that there's no question about this. So here, I'll move this over to the right. We'll use my purple pen and say equals 0I -3 minus this, plus 0K. And now what I'll do is I'll multiply this. Oops. I'll multiply this times that, plus this times that, plus this times that. If you look at that, all those terms added up are going to be 0. So the dot product, so this velocity is perpendicular to that vector. Obviously, it's the same thing with the other. This times that, this times that, and this times that is all going to give you 0. So this vector is perpendicular to that vector and to that. So we've satisfied at least that. Now let's look at this and figure out what this means and how we can interpret this. So this is as if you were on B. So in other words, here, let's do it this way. We're going to take a snippet of, oh, that's right, new. This time I'm going to do the freeform. Okay. So here's what I'm taking. So I'm going to take that. I'm going to get rid of this now. And let's see. So there's the link. So I'm just looking at that link. Since I am glued to B, it is as if B is fixed. So the person sitting here is glued to B. He sees this vector going out here, sees X and Y, a positive rotation, which means in his mind, he sees that. So technically, what is it? V is equal to omega r. You go out there 3 meters, you go straight down, so that's 3 meters, which is the r, times omega, which that's the omega. So in fact, this makes sense. So in this term, that's what you should really think about. Individually break away that individual link, treat it as if whatever the lower indice is fixed to the ground. Look at the vector and the rotation about that and see if that makes sense to you. If it does, then that's actually what that term is. It is as if you were pinned, a person was pinned here, and this was fixed, and this is the velocity of A if that person was pinned there. Now, how do we complete the problem? Let me get rid of all this junk. It's all on the video, so yeah. Here's how we complete the problem. I was remiss in copying this down, plus this. This is just some number here. This right here equals to this right here equals to plus this. Well, what is that? Actually, that is velocity of A, and this right here up here is velocity of B. So I just carried them down. So really I should be better about this. Here's velocity of B. Here's velocity of A. Here's velocity of A. So I'm just copying these terms down and not filling them out until now I'm here. And actually I don't need to copy this term and that term. I just want to make things fairly simple. So let me go find velocity of B. Velocity of B is this. Now here's the beauty. You can do that. Do a copy. Go down right here and sort of put it right there. And then erase that. Then I can find velocity of A, which is all this mess. And let me copy it. Is it not working? Oh, I'm pushing the wrong thing. Oh gosh. Okay, well, we may have to complete this out next time. But at least you see the problem from beginning to end. What you see here, believe it or not, is two equations. You have an I equation and two unknowns. Your two unknowns are this and this. Your two equations have the term associated with the I components. Oops. How do I do control? Okay, you got the I components, that, and then you have the J components. These form two equations and two unknowns. So I guess I could write those down. So 6 cosine 30, this is the I equation, is equal to minus 2 omega BD or BD cosine 30. That's this term's equal to that one. Then you got minus 6 sine 30 is equal to minus 3 omega AB. So just like that, you got two equations. You can divide these terms out. You can solve for this one, and then you can solve for that one. Once you have those two, you can go back in up here. Well, that one you don't have to do anything to, but this one you can put in the omega BD right there and solve for the velocity of B. You can find the velocity of that pin point there. And then you have the velocity of, so that's how you do these problems. So the identifying thing is you write the velocity, relative velocity along a link. The pins are connected from link to link. And so we'll do several of these along the way. And you'll find out that they pretty much work all the time, even for big, long, weird links. The things you've got to recognize is what is a link and what isn't a link, and that's pretty much it. So it's just a matter of going through the process. Sometimes you'll find these problems can take an hour or more just because there's links you got to, just the time it takes to go through. That it's not that complicated. Once you do one or two, you find the sequence and then you're just doing it. You know? So I'm sorry I ran over. But according to Mickey, oh, 3 minutes over, sorry. So I guess I'm done. So I guess wait, today's Monday, right? Yeah, sorry about last, was it Wednesday? And then I ended up doing uh helping with a thing at the high school on Friday, so that's why I bailed on you. Sorry about that. But we've got the internet now. And so I'll make it up and do a lecture somewhere along the way. You too.